All right, folks. I see that most of the people are here. I think we're still waiting on a few more, but we'll get started. So welcome to the 2020 R conference pre-workshops. You folks are lucky. We are starting your workshop actually the week before. The conference and most of the workshops are next week, but our instructor, Max, and his TAs, Julia and Davis, thought it might be nice to split up your workshop over 4 non-consecutive half days to make it a little bit better for you. I think most of you will be attending the conference next week. For those of you that are, I'll see you next week. Those of you that aren't, we hope we'll see you at another one of our events. Next week's going to be very busy. On Monday, we have the meetup featuring Miles McBain coming to us from Australia. Then Wednesday and Thursday are the days 3 and 4 of the workshop you're currently in. And then Friday and Saturday are the conference itself. We are very excited. Last year was the first year we did workshops, and Max, again, taught a very popular sold-out one. Seems like he always just draws a big crowd. And we're very excited today. I think it's a surprise to have Julia and Davis here helping out. They are core contributors. I'm not sure that's the right term, core contributors. They're important people in the tidymodels world. So we're very excited to have them here. I didn't even tweet about it. I wanted you folks to be surprised. And for those of you that have been to our events before, I think you know how much fun we really like to have and how, for lack of a better word, friendly we like to be. I want everyone to feel free to chat, talk. When I say chat, hold on, let me rephrase that. Since we're virtual, it's a little bit harder than usual. So when I say chat, I mean during breaks and the text chatting. I want everyone to get as friendly as you can, get to know each other, because a large part of this community is the relationships you develop. I can't list how many friends I've made through this community, how many people have gotten jobs, how many colleagues, and all sorts of great people you meet. So since we're virtual, things are a little bit different than when we're in person. We have this platform, Hopin. It's sort of taken over the world a little bit lately for conferences, and we hope you will enjoy this platform. And the goal here is for everyone to be in this session we're in right now. We ask that while the lecture is going on, you feel free to keep your cameras on, but please mute your microphones. This way we don't hear a lot of background chatter, people talking. If you have questions, there are 2 Slack channels for you. One is called, let me make sure I just get the name exactly right. I believe one is called Max Kuhn General. I'm paraphrasing here. Max Kuhn General Questions and Max Kuhn Technical Questions. Julia, it's actually Max Kuhn RConf 2020 General, but close enough. So in there, during the sessions, please feel free to go in there and ask any questions you want. Julia and Davis will be in there asking questions. In case it gets really busy, I'll be there, as well as Michael Bagelmacher from our team, and we will do our best to help you out. During breaks or when there's like question and answer time, we'll then say, okay, question and answers, please feel free to use your microphones. We can all jump in and do our best to make a Brady Bunch style chat. We'll see how this goes over the rest of today, and we'll adapt as needed. But please do go ahead and use the Slack channels for questions while Max is lecturing. And during breaks, we will have everyone turn on their microphones and cameras if you wish. I know there is a separate breakout room during breaks. We will try to take frequent breaks, frequent being relative term, when we feel the need it's time for a break. And there's another room to go hang out in, just sort of chill, relax. Bring your favorite beverage, alcoholic or non-alcoholic, whatever you want to do. Grab a slice of pizza, because that's all I eat. That's all I encourage everyone to eat here. And just everyone have a fun time. So I hope everyone's set up. If you have any questions, please feel free to ask us. And I see Amada has a question.
Just wanted to say, for those of you sharing your video or audio, if you want to stop doing that, on the top right, you hit leave, and you don't actually leave the session. You just leave as being a panelist-looking person. Yeah.
Great. Thank you very much. That's actually very good. Do you have any other tips?
No, not right now. Thank you.
All right. If you do, let us know, because you know this platform much better than all of us combined, I think, except for Bill. You and Bill are pretty good on this.
Today we are.
I can, but I was told earlier not to. Would you like me to?
Go ahead and do it as backup.
Okay. I was all set up to do it. I will start it now.
Okay. All right. So, folks, if you need more information, you can go to rstats.ai. We've probably been there. You get more information about the conference. The Slack you are in is for the New York Open Statistical Programming Meetup. So you'll see in there's a channel dedicated to R help. There's also Python help, Git help. There's even a Julia help, though I realize that the Julia contributors, they need to get them on Slack because they know a lot more about Julia than anyone else, I guess. They're the people who wrote it. There's also an events channel if you're looking to find out more events that we put on, mainly the meetup and workshops throughout the year. And there's also a job posting. So if you are looking to hire or you're looking for a new job, go to the job postings channel and see what's put up there. People occasionally post jobs looking to hire. So it's a good place to find work. And if you're looking to hire someone, it's a great place. So with all of that, if there are no questions, or there are questions, go ahead and ask them in the Slack. If there are no other questions, though, I will turn this over to our super awesome leader for today, who's going to guide us on a magical mystery tour of the world of tidymodels. So take it away, Max. Thank you.
All right. Thanks, everybody, for coming. This is going to be new for everybody. I've done only a few virtual things this year, so hopefully if we're not great at it, hopefully we'll be getting better at it. So introducing myself, I'm Max Kuhn. I've been working with R for, feels like forever, for like many years since it was a thing. Mostly have written a lot of packages for modeling and data analysis and things like that. I currently work at RStudio, and we'll mostly be talking in this course about using the what we call the tidymodels packages, which are packages that are sort of based on tidyverse way of doing things, but more about modeling rather than visualization and data manipulation. So just some preliminary stuff for the next few minutes. We already mentioned this Slack channels. Again, I'll be stopping, I usually stop very often during a talk to see if people have questions. But the purpose of Slack channel, as opposed to Slack, or as opposed to the hop-in Slack chat facilities, was for people to get, like if you're having trouble installing a package or something like that, you can simultaneously get help on that in the technical channel from Davis and Julia. Or if you have a question you want to sort of queue up, when I go to stop sort of at slides, during the talk, I'll check those there. So we just wanted to avoid people accidentally like talking over each other and things like that, and so on. So that's the deal behind that. The slides and everything, hopefully you have them. We sent out some emails, but if you don't, what you're going to want to do is go to GitHub. So github.com/topepo, TOPEPO. And then when you go there, you should see on the top something that says NYR 2020, and that has all the code and the slides in it. So if you have trouble getting this, maybe in the technical channel, I'll let people know. If you haven't ever used GitHub before, they can help you there. And if you click on that link, you go to the repository for these slides. You can see there's HTML slides in here. There's some other stuff. One other thing I'll point you towards is there's a file called code.r. And what that does is I've extracted all the R code that is used by participants from all the HTML slides. So instead of you like copying and pasting things out of HTML and R, which actually works fairly well, you can just open this. I'll show you in a minute, but you can get the R code that we're running at any given time from this file. This is probably the better place to go to get it. So anyway, if you have a GitHub account, what you would do is you would come up here and clone the repo, like open with GitHub desktop. If you want to, you don't have to, but if you want to, you can fork it and so on. But you can open this in GitHub, which is probably the better way of doing things. If you've never used GitHub before, or you're like, what's GitHub? One thing you can also do is when you click on this green code button, it gives you the chance to download it as a zip file. And when you do that, this whole repository will go to wherever you keep your downloads as a zip file. You can unzip it, and then these files will be here. The downside of doing that is what I'm going to try to do at the end of every day is during questions and things like that, I might type in some like live coding stuff. And I usually save those in a file usually called Scratch. And so I will update the repo with Scratch at the end of every day. So you can see like, oh, what was that thing he was talking about with ggplot or whatever? And you can get all the things that I've typed in. So if you're not a GitHub user, you would just want to come back at the end of the class maybe and re-download a zip file that'll have all those changes in it. So that's how we'll handle the code and things like that. Now, we did send a survey out and ask people if they wanted to run locally, which not everybody, but most people said they wanted to run on their own machine. And we sent out installation instructions. Those are in the README here. So hopefully this is done, but if you're just now getting here and wondering what I'm talking about, to run a lot of the code that we have here, you're going to want to basically run this code to do the installs. That will probably not take forever, but it's more, it'll download more packages than what we see here. And then, these are the ones that we would suggest maybe testing your installation on. If you have trouble doing this and you haven't already done it, then let people know in the technical channel. In just a second, I'll show you how to use the RStudio Server instances that we have set up. So what normally happens when we teach this class at our at the RStudio conference, we'll have like 200 or 300 people there, and maybe about a halfway, like in the first half hour, some people who thought they could run locally, but maybe their work has their computer configured in a way that makes that difficult. You can also jump into the RStudio sessions there, like the RStudio Server sessions. So if you do have that happen and like you're worried about like, well, geez, I can't do anything right now, go to the technical Slack channel and then tell people like, wait, what were the instructions for getting on RStudio Server Pro, and they will walk you through that. I will do that in just a second. So let's see, let me just check general here while we're at it. Okay, great. All right, so if you have the slides and all that, then let me show you how to use RStudio Server Pro. The instructions are in the second slide in part 1. So there's part 1.html, and we have a link here that you will go to. It's rstd.io/class. So I'm just going to open that in a new tab here. So when you go there, what you get is, let me reload my session. It'll ask you for a workshop identifier. And so then that is also on that slide where it's, I don't know why they named it this way, it's Q3 NYRML with some underscores. So you would just paste that or type it in here. And then hit submit. So let me just let everybody catch up if you're there. Q3_NYR_ML, and it's rstd.io/class. So then once you've done that, you would hit submit. And also in general, if I'm speaking too fast, like you can let me know. Good, thank you, Davis, for mirroring this stuff. You hit submit, and you'll get something that looks like this, classroom information. There's a link here. You'll click on this in a second, but this should open things up in a new tab. You can always like right click and open a new tab if you want. And then you'll have to type in a username and password, which are right here. They'll be the same for everybody, so it's not really all that specialized for you. So opening that new tab, you get an option of RStudio Server Pro and Connect. We're using RStudio Server Pro. And then clicking on that, I'm going to start a new session. This is one that I tested with earlier. So you'll just click on new session here. And then you can leave everything as is here. It's all set up for you and start session. I did this already this morning to test it. You most likely will get a prompt for our username and password. And then again, they're here on this page. NYR, ML, and tidymodels is what it is for everybody. So once you've cleared those hurdles, this is what you get. You basically get an RStudio IDE. Everything's kind of set up for you. So all the packages that we have listed as being needed are installed. So for example, if I just do library tidymodels. It always takes a second. It loads fine. I did notice this morning, I asked our people about this and it's okay. These are, for some reason, a couple of these packages have the development versions installed. That's not a problem at all. And you won't, knowing the differences in some of these packages with their GitHub versions and their CRAN versions, there's nothing so substantial that you would notice a difference or that there is even a difference. So so that's all fine. So if you see these really long numbers here, don't worry about that. It's just a little bit of an oddity about how they set things up. So everything's installed here. And then if you come over to where we have files, there's a thing here that says class repo. And then,
hey Max, can you zoom in a little bit?
Like that?
Yes.
Okay, thank you. So if you look and see class repo under files, this has everything in the GitHub repo. So so everything that you would have cloned if you hadn't, or downloaded via zip file, is all in here, and so on. So this is pretty much what you need for the class. Tomorrow, what I'll do is I'll show you how to update this from RStudio Server Pro. Assuming we have some scratch file that needs to be updated, I'll show you how to update that to get that in your repository. So I'm actually going to run locally. It's a little bit easier for me to do that. So I'm going to leave this open. But again, if you have questions or anything like that, then go ahead to the technical channel and let people know, and we can work that out. Other preliminary stuff. So the way this is going to work is there'll be stretches of sort of like lecture. There'll be code, and I will periodically execute the code as I go. And then what I tend to do is, at least when I'm teaching in person, is in my head, I kind of know what good breakpoints are for people to ask questions. So I'll stop and look at the general channel and see if there's anything there and answer any questions you have there. Also, let me just pull that open, the general channel here. So for example, one nice thing about this is you can actually, if you've never used Slack before, you can type in things and put code in really easily. So if let me just get some code here, something a little more substantial. So what you can do is you can copy code out of here if you have a specific question. And if you're doing this, and you've never used Slack before, you can use 3 backticks and then paste in code and then 3 more backticks. And then when you hit enter to execute that, it'll look like code. So if you're trying to say hey, I saw this, this portion of code here and I have a question specifically about this, you can tell me what slide it is and everything, but if you feel comfortable enough, you can just use backticks to format it as code. So that's something you can do. What else? There will be some hands-on bits. So there will be a hands-on part at the very beginning here where we just do some general investigation into a data set that we have sort of queued up. And then what I'll do is there's a timer on that. It's like 10 minutes. Everybody will go and do their thing with the data set. I'll keep an eye on the general and technical channel during that time. And at the end, I'll sort of, at that point, I'll ask questions like literally ask the class what they thought about things, and if anybody has suggestions of things to look at. So you can unmute then during that period and tell us what you think. And, some of us might do it at the same time, so it might be a little bit awkward, but we can manage through that. So that's the general gist of how this is going to work. Is there'll be maybe 5 or 10 slides of me talking about code or talking about what is resampling or what do I mean by overfitting and conceptual things, and then we'll do some live coding at the exercises and breaks for questions. Okay, well, I'm going to go ahead on with the or before I do, there's no questions in general, but if you have any, put them in there and I can answer them. But since there's none, I'll just go ahead and proceed. So, you're here for, well, it says applied machine learning here, but it's machine learning in R basically. So normally if you're new to R, short discussion about R and modeling. One thing you might ask is like, well, why should I use R for modeling? The great thing about R is it has a lot of cutting edge models. And what we find in different problem domains is that people who work, let's say, in time series or in image analysis or different areas of modeling and statistics and data analysis, they kind of have like their languages they feel most comfortable developing in. And for like deep learning, that might be Python, but for time series, it might be R. Or if you have people who are doing research on tree ensembles, it's more likely than not that they tend to use R more than other things, or maybe we'll have like an implementation of R earlier than they will in other areas. And so one nice thing about R is, for the most part, it has fairly cutting edge models. The machine learning and modeling in general is very, very rich in R, probably richer than any place else. It might be weak in this area or that, but overall, I don't think anybody can really match what is in the packages for statistical analysis and for predictive modeling and machine learning. Another good thing about it is R and R packages are generally developed by people who use it every day. And so R originally was an offshoot of this thing called the S language, and it was written by two gentlemen, no pun intended, Robert Gentleman and Roth Ihaka. And so they wanted a version of that language that they could more easily use for their research and for their teaching. And so the core R people, the people behind the scenes in the canonical part of R, they use this for their research, their teaching, and in some cases their jobs. So this is not the situation where you have somebody who's like a software developer and doesn't do modeling or doesn't do data analysis, designing software for those things. Almost everybody who contributes to R has a significant portion of data analysis in R. So from that sense, it's nice because you tend to get features and things that are very relevant for what people do in R. So it's very good. And the whole like eating your own dog food, that sort of analogy is very much true here. So most of the R packages I built before coming to RStudio were completely based off things I had to do at work, like every day. And so the features that were in there and the direction that I took those packages were almost always motivated by things that I needed to do like that week. And if those things didn't work, then it was very problematic. So we just make sure they work. As I mentioned, R is based on the S language. S language is very mature. The first, what I consider the S language as we know it today, was really around in the mid to early 80s. So that's the 80s, right? It was, many people weren't born by that point. I was very young at that point. And if you take like what we call the white book, which is actually sitting right here next to me, most of the code, if not all that code in that book, still runs in R today. So, when R was designed it's what we would call now a domain-specific language, but the great thing about it was designed for data analysis. So, if you look at other languages that have packages or things like that for data analysis, that's very good. But, sometimes you can say that the strength and weakness of the S language is that it was built for data analysis. And it, again, is very, very mature. Another thing that John Chambers talked about this a few years ago at the UseR conference, is the one thing that is inherent in R that it inherited from S is that it's very good at linking to other applications. So the original concept of the S language was basically a bunch of Fortran wrappers, that he had all these people at Bell Labs that were doing all this computation, and they needed a front end, basically a nice front end where they could do other things in interactive data analysis without doing it in Fortran, if that's even possible. And so from the very beginning, the S language has been able to port to C and Fortran. And then, that part of its DNA is continued with Python, Java. So everything you can think of, whether it's TensorFlow stuff or Google Maps or Weka or Stan, the smart thing about R is it doesn't try to be everything to everybody. If there's some type of computation that there's already existing, let's say open source implementation that is sort of the gold standard, we tend to link to that or to import the source files for that and make an R package out of it. So, it's the language itself has its strengths and weaknesses. In a lot of cases where it has its weaknesses, it passes things off to C or C++. So that's you really inherit a lot of functionality by doing that. And sort of, I already mentioned this already. The machine learning environment in R is very rich. So that's you actually have like an embarrassment of wealth. Very often, it's not so much like, should I run random forest? It's like, which one of the 20 random forest packages should I use? So that if there are any problems, that's probably one of them. So downside is, it's a data analysis language. For me, it's always been high performance enough, but a lot of people have really, really intense needs for speed and or storage and things like that. So, it does hold, for mostly, not always, but it does hold data in memory. So, if you have a terabyte of data, you need memory for that. R is very good at not making copies of things in memory, but that is a limitation. But with all things in R, there's always a package that sort of fixes that. So if that is a limitation for you, let us know, and we can give you references. There are a lot of packages and data analysis packages that are specifically for out-of-memory systems and things like that. Or, like I mentioned earlier about porting things out, you can even access R or have R do the computations in a language and then bring them back in. So, when I used to use R sort of in production, for example, I used to work in a molecular diagnostic company where I was running the algorithms for their infectious disease diagnostics. So, you would go into a hospital with a really, this is not a COVID story, but like a really bad cough. And if they're worried that you have tuberculosis, you get a sample and they put it in this machine and the machine would spit out a number that basically was like, here's the probability we think you have tuberculosis. And so we would do all that prototyping in well, back in the day it was S+ because R wasn't a thing then. And so what we would typically do is we would do our algorithm development in S. But we couldn't put that really, or we didn't put that on the instruments that go into the hospital labs. So then we would translate that to C and then put the prediction equation in like that. So, we're getting better and better about deployment in R. But it does have some limitations in terms of performance for, like, I would argue maybe like 10% of all cases. Depending on the type of machine you have and computing resource you have access to, it for the most part is pretty good, but not for everybody. Now, one of the problems that is an internal problem that I've been sort of dealing with my whole career is there's an issue of consistency of interface. And so, R is an open source language. Most of the code that we use are in R packages, and those R packages are written by different people, and different people have different levels of experience with R. Even people who do have a lot of experience in R think about code in different ways. And so what happens sometimes is you have people who just program differently. And so if you're using a variety of packages in R, one sort of stumbling point sometimes is that they have very different interfaces or they do slightly different things. And so it's not quite the Wild West, but and we'll show you how to get around all this. So we can kind of negate this problem, but it's worth talking about. As we'll talk about in a little bit, for example, there are two main ways you can specify a model in R. One's using something called the formula interface, and the other one is sort of what we call the non-formula or data frame interface. And if you want to use an R package that you're interested in, and the formula method really well, you might look at it and be like, oh, there's no formula method, which means I have to do things differently than I would normally. Or vice versa, maybe there's only the formula interface and you've already got your data in a way that you don't need the formula. So there's a little bit of inconsistency about that. If you've ever heard the phrase dummy variables or indicator variables, we'll talk about them in a bit if you haven't. But most of the time, most modeling functions will generate those from your data, but not all of them do. So if you want to use one package you're particularly interested in, sometimes you have to do a little more work to get everything ready for that package that you would not have to do with other packages. So that's a little bit of an inconsistency. Another example is sparse matrices. We have, I think, a pretty rich sparse. Well, we have multiple sparse matrix implementations in R, and they're fairly mature, but not all the packages use them. So, so if you have very sparse data, you can do that in R, but again, for some packages, it's easier than others. So as an example, this interface issue, I've sort of been showing this slide for a long time. What it is it shows different syntax options if you're fitting a classification model and you want to get class probabilities. So these would be like, the probability of event A versus event B. Let's say we have two classes. And let's say we're doing some data analysis and we start off with like a linear discriminant analysis model, LDA, in the mass package. And if you have your model object and you want to make predictions to get the class probabilities, if you just run predict, you get both the hard class predictions as well as the probabilities, so you don't really have to do anything. That's really nice. You may then try to use a logistic regression using the basic stats package and the GLM function. And then when you go to make predictions there, you have to remember to do type equal response, and that gives you the probability of the second level of your outcome. So, that's just something to think about where you're like, right, logistic regression, I have to do that. And then you might have, after that, done a boosted tree using the GBM package. And that also uses type equal response, which is really nice. But you also have to tell it how many trees in the ensemble to use. And so like you type it in, you forget that, and you hit enter, and it says, well, how many trees? You're like, oh, right, I got to remember that. And so you can see sort of like how this works if you're going to try different models. Sometimes it's a response, sometimes it's prob or probability or posterior. And these always use the predict method. There are some packages that have their own specialized function to do the predictions. So you don't even know what function to call automatically. These all use object-oriented programming to direct you to the exact code that needs to be used. Whereas this one, you have to remember to use this special function in R to get predictions. So that can be frustrating. And so, what's happened over the years, I started working on this problem like 2003. In 2005, came up with the carrot package to sort of solve this problem. There's other ways to do it, like tidymodels solves it, MLR and other sort of infrastructure packages in R solve this problem, but it's there. And so it's worth talking about. So, the good news is in R, you have a lot of freedom to make interfaces that you think are interesting and cool and the right way to do it. But the downside to R is people have different ideas of what interfaces should look like. And so you have to deal with this heterogeneity a little bit more than you normally would, especially compared to something like Python. So I'll stop there and check journal. Okay, no real questions there yet. Okay. So we're going to exclusively really talk about the tidymodels packages. So the tidymodels repository contains a bunch of packages. They're fairly modular compared to something like Carrot, which had everything in one package. And so what we've done is we follow this sort of tidyverse example and have like a meta package called tidymodels. And when you load that, it loads a bunch of core packages that we think are the packages that you'd want to use to do most of the work that you want to do. There are other tidymodels packages that we don't load that are more specialized. And then we also, in this collection, when you load this package, you also get things like ggplot and dplyr and tidyr. So you get a lot of core tidyverse packages too, because we use those quite a bit. But there's a lot more. If you ever want to look, go to the GitHub repository for tidymodels. And we have a lot of packages in there that do various things. There's packages that Julia works on and others for processing text. We have packages like tidypredict is a package that can take some of your R objects and convert them into SQL expressions. So if you fit like a random forest model and don't want to carry around a random forest R object, you can convert that to SQL and put it in your database and things like that. So that's not what we consider a core package, but it's there and it does a lot of really great stuff. So there's a lot more in tidymodels than what we show here. All right, so let's think about some data. You know, we in the last, I don't know, in the last couple of years, I've been trying not to use the iris data for everything. And then in the last year, I think, if you haven't heard, in the statistics sort of domain, we've all decided to never talk about iris again, because it was originally published in the eugenics journal. So we're like, well, that's not good. Let's not promote that. And so in some ways, this Ames housing data has become like new iris. It's an excellent teaching data set. So if you've seen it and you might be a little bit tired of it, sorry, we're going to use it for a fair amount of things, not for everything. But it's a very good data set to learn on. And what it is what was it, 2010, 2011, some people worked with the Iowa State or the Ames, Iowa Assessor's Office in Iowa State University's at Ames. And what they did is they basically got a database dump of all the houses in Ames with things like their location, information about their lot, like what's the shape of the lot, what's its size. There's all these fields about, or columns about, components of the house, like is there a garage, what's its square footage, is there a pool, and so on. Not probably everything you could ask about a house, but like a lot of predictors. And we got that for a little under 3,000 properties. So if you want to read about it, there's a paper here. There's links to a PDF that you can look at. The raw data are also on the website for this journal. We're going to use a processed version of it for the most part today in a package called model data, which is loaded with tidymodels. But if you want to look at the raw data, you can look at it here. Here's a little visualization of the data. So this is Ames. And so I've colored the data points here by their self-reported neighborhoods. So there's a lot of interesting things happening here. We're going to do sort of like a general look into this data. I'll ask questions about this and see if there's things that people noticed, or if there's anything weird that they notice about these data, because it does have some sort of quasi weird things about it in a good way. One thing I'll mention that's not like a spoiler alert is when we look at some of these houses with their self-reported neighborhoods, they're not quite, I don't know, consistent. Where like the yellow here, if you can see it, is the Northridge neighborhood, and then next to that is Somerset. But then you have like somebody's house over here, like I'm Northridge, like down with Somerset. So, some of these, I don't know that they're errors. They were reported by somebody, probably the owners, as being in what neighborhood they think they are in. But, there's some inconsistency. Sometimes you see like over here, we have a lot of data for North Ames, and next to that is Northwest Ames. But embedded sort of in between those is a little neighborhood called Briardale. So, the neighborhoods are very helpful, and we'll talk about them more. But there's a little bit of what I would call weirdness about the data. Like, you have people on one side of the street here that are in Gilbert, but literally across the street are in North Ames. So there's just some aspects of this data that are interesting, again, from the point of view of data analysis. And so, yeah, so this is the sort of literal bird's eye view of the Ames data. So here's what we'll do is, if you've never seen the tidyverse, then we want to get you a little bit introduced to that. Most of the code we'll use today is very high level, so you don't need to be writing, a long series of piped expressions when you do data analysis with tidymodels, but we feel like we should talk about the tidyverse a little bit. And then after we get through this, we'll have a 10-minute code exercise that, everybody will go off and do their thing with the data, and then we'll ask questions at the end of that. So we're going to require you to play along, because I'm going to be prompting the audience for answers to some questions. It won't be that painful, but yeah, you'll have to have seen the data to answer them. So when we talk about the tidyverse is really like a dialect of R, where the way the syntax is written is in many cases different than what base R would do. So for example, So another data set we use quite a bit is called the penguins data. And that has a bunch of data on penguins from 3 different islands. It has a bunch of different fields in it. I say fields, and that drives Davis and Julia crazy, so I'll try to say columns instead. So let's just look at that data real quick. See, what did I do? Oh, sorry. So the data set has 344 records in it. It has a factor for species, a factor for island, has some data on the bill length and depth, something about the flippers, their body mass and sex. So it's not like a really complicated data set. Going back to the notes, if we wanted to know what columns, or if we wanted to say, let's select the columns that were related to the penguin bills, what we would do is we would say something like penguins, penguins, and then subset using the quoted character names of the data to get those columns back. The tidyverse, we tend to do things with what we call unquoted variables. And we also tend to use a lot more functions than base R does. So instead of like doing the subscripting, we tend to use functions for things that have names that are very clear. So we're trying to select columns. So what we would do is we would say penguins, and I'll show you what this means in a second. We would use well, let me avoid the pipe operator for now. We'd say select from penguins. And instead of quoting the names like we have here in a character vector, we tend to use set it up so we can use unquoted versions of those. So if we just wanted to select these columns from penguins, we would do that. So it's kind of a difference between like having more base R subscripting type stuff with quoted like character vectors of columns and things like that, as opposed to just typing in their names bare along with a function that does it, that is it's not a function name that describes what it's doing, like select. So that's like one big difference between base R and the tidyverse. And then I started to do the pipe because we use it all the time. If you've never used the pipe operator, let's say we have a function like the dplyr function inner join, which is like a SQL join between, let's say, data frame A and B. One way we could write that is to just say, this new variable gets the results of running the inner join with the first argument being A and the second argument being B. That's syntactically equivalent to doing this, saying merged is going to be the result of running the inner join function. The first argument comes before the pipe and gets substituted in the function call right here before B. So what happens is the thing that you put on the left side of the pipe is the first argument to the thing that comes after the pipe. So you can see I have A and B here. The A is not listed here because it gets sort of inserted by the pipe in place of this. That might seem like, on the face of it, if you've never really used this, that might not seem much of like an innovation, like, okay, cool, why would we do that? It's kind of weird. But the thing is, I'll show you in a minute, we can sort of nest these calls together using the pipe and do very significant data analysis in a series of piped operations, as opposed to having 5 or 10 separate calls to the same sort of object over and over again. So for example, here's the aims data. So if I were to load the tidyverse package, I from that would get the readr package, which can read data. As an example of how the pipes works is the first argument to the read underbar delim function is the file name, which could be a URL like here. So what we can do is we could pipe that URL into readdelim, which would be inserted as the first argument here, and then give it any other arguments that we want, and pipe that into the rename function. And then what this would do is would take any variables that have a space and substitute, instead of having a space, we'll substitute in an underscore for the space. So it's renaming whatever variables sort of fit this pattern matching, and then runs this function on those to rename them. But there's also, to be consistent, the sale price of the house is written as sale price, one word. And so to be consistent, there's no space there, so that wouldn't be affected by the rename. So we can then do another call, instead of rename at, just use rename here and make that consistent by calling it sale underbar price. And then there's one or two rows in this data set that don't have any information on their electricity. So I generally don't get rid of missing data, but there's nothing better to do about them here. So we can actually run a row filter that takes like a conditional statement. And then we can select with negative values here to get rid of some columns that we don't really use. So this is an example of some dplyr syntax. A couple things about it is, when I talk about the value of the pipe, if we were to equivalently do this over and over again, we'd have like 6 statements here that say aims, prices, gets, and then the result of a bunch of different lines. And this tends to be a little bit easier to read in many cases than just a bunch of scripts where you're just constantly renaming the same thing over and over again. So there's a lot going on here, and this is a little clunky way to demonstrate that. But this is a good example of how we use the pipe. Something else you may have noticed here, if you've never seen this, we do dplyr colon rename, or dplyr colon filter. So what this is called calling a function by namespace. And what that means is there's a dplyr function called filter, and there might be filter functions in other packages. Most notably, there's a function in the stats package called filter. And the thing is, when you load libraries, if you just type in filter, you get whichever one was the last one that was loaded. So if dplyr got loaded and then the stats package got loaded in your session, and you just type in filter, you get basically the stats one. And so there's 2 different ways of going about dealing with this. The first one is just to be really specific and say, I want to run the function filter that's in the dplyr package. And that's what I'm doing here. This isn't really the best way of dealing with it, but when I teach, I tend to use this method, which again is, if I use the phrase calling something by namespace, that's what I mean. It's the package name and then the function. The other way of going about it is Hadley Wickham wrote a package called conflicted, and deals with these name conflicts. And so in conflicted, what you can do is at the beginning of your session or beginning of your R script, you can load that package and say, well, dplyr filter always gets precedence over the others. So, and it will basically set up in your session that when you type in filter, you can say which filter that you should get, independent of how they were loaded. So conflicted is a really elegant and good way of doing it. The reason I don't really do it in training that much is because I think what people are going to do when they go home and start using this, they're just going to be copying and pasting things out of these slides and putting them and changing them for their data and things like that. And this is a little more foolproof than that if you're just taking out little bits and pieces of code. Because you don't necessarily know that if I didn't have this in here and you ran this without running conflicted, you might have problems, especially for rename and filter. Those are the 2 that I have the most issues with conflicts. So yeah, so those are the things I wanted to bring out about this code chunk. Another nice thing, if you've used base R a lot, is there's a lot of data manipulations that the tidyverse allows us to do that are very easy compared to their base R sort of analogs. So for example, let's say you wanted to get the mean price of the houses in the data set in thousands of dollars, and you wanted to get them for different values of alley. So that the column alley has values of gravel or paved. But if you didn't have an alley, the original data that's in the raw version here has an NA value because there's no alley. So, they could have encoded that and said no alley or something like that, but they just left those as missing because it doesn't have an alley. So you don't know whether it's gravel or paved. It just doesn't exist. And so let's say you wanted to get the mean price of houses in thousands of dollars and the number of houses per value of alley. And so what you can do is you can take a data frame and group them. So if we do a group by, it means that all the calculations that happen after this happen for every unique value of the columns that come after this. So you can have like multiple columns in group by. And so from there, the summarize function generally is used to take a data set, and you don't have to do it this way now, but produce, let's say, like a 1-row summary of the data. So in this case, what I'm going to do is running summarize makes a column that's called mean underbar price, and that has the mean sale price in, again, thousands of dollars. And then we can also, if there aren't any NA values in price here, but if there were, we can count the number of data that were used for this mean just by summing up the indicators for not being missing. And then the results of that, you can see that alley gets nicely added as a column. It keeps the NAs here, so we don't lose them. And then we have our summary statistics. So if you've ever used like the aggregate function in R, it's not like a nightmare, but it's just really kludgy and it's really inefficient in base R. And so there's some nice little syntax sugar that you get from using the tidyverse and so on. All right, let me see if there's any questions. Okay, so question, something I've been curious about since watching one of the keynotes at user, how much speed are we giving up when we use the pipe versus nesting functions? That's a great question. It's very relevant. I think the core team explained our 4.0 changes, that differences between these two operations. Curious if we have tested the differences yet. Yes, that has been a hot topic of conversation. So there is a little bit of a price you pay for using the pipe versus, let's say, having, there's a couple alternatives you can think of, like, is it faster than having, so there's, let's see, there's 5 things that we do in this pipe here. We read the data in, we rename again, we row filter, and then we column filter, right? That's 5 things. So if we test that against one line here, where we nest all these statements, like in a really long one-line statement, where this, the base R equivalent of this is nested inside of the base R equivalent of this, which is nested inside this, and so on. Yeah, there is a, I don't know that it's a huge, in fact, I don't even know that it's a noticeable change in performance, but it's a real change. You could also contrast that against a situation where you just had 5 different calls to these functions without the pipe. So there is some overhead. I don't feel that it's that bad. This is one reason I think there's going to be a base R pipe that's going to work probably a little bit differently than how the dplyr or McGritter pipe works. But literally, like in the last week, it actually was 2 days ago, we had a long discussion in the tidyverse group about ways we could overcome some of these things. So, one of the people in the group listed about, I don't know, it was like 5 or 6 different ways we could re-implement the pipe, or not re-implement it really, but other ways of streamlining the pipe to make it more efficient. So I think that for me, the answer to the question is, for the types of work that I do, I've never run any code with the pipe and said, geez, this pipe is killing me. There is a real difference, but for me, it's never been significant enough for me to be really worried about. But that said, it is something, especially since that keynote, that we're working on to try to make that more efficient as we go. So I would suspect that, well, Davis probably has a lot more insight to this, and that he's just posted something in general, which is probably way better informed than what I would give you. So that's a good question. There is a small, I consider to be a small computational price to pay using the pipe. Yeah. All right, another thing that we'll talk about doing, and we'll mostly talk about this in manual calculation. So you shouldn't have to do much of what I'm about to describe in your data analysis code with tidymodels But for some of the things that we show you the not the low level code way of doing it, but we will show you some per code, but you shouldn't have to use it very often. Per is a really cool package. It's self-described to be like a functional programming package, which is totally true. But a lot of times the main uses of per are really like better replicating functions that are in base R. Specifically like the apply functions in base R. So I think most people when they use per use it for sort of like the souped up versions, tidyverse versions of apply. And that's what I'll talk about here for a few minutes. Before I get into per a lot, I just wanted to make a small data set, toy data set that we can look at to show how it works. So what I'm going to do here is create something called mini aims. I'm going to take the aims data that we had earlier. I'm only going to keep 3 columns, the alley, the year sold, and the sale price. Get rid of things that have missing alley, so it only have 2 levels, gravel and paved. And that's a smaller version of the aims, and we'll use that. So if you were to look at the first 5 rows of mini aims, you can see that those first 5 are all paved alleys. Here's their sale price and their year sold. So one thing we can do in base R is we could run split on this data set. And base R required you to give it also a vector to say like what should we split by. And so what split does is it takes this original data set and it creates a list out of it. And those list elements are basically subsets of the original data set based on whatever data you gave it afterwards in the function call. So if I want to split the data so where I have a list where the first element of the list is just the gravel alley data, and the second one would be just the paved alley data. That's you can do that using the tidyverse, but we thought we'd start with base R here. So the results of this is a list with 2 elements. The first element is a data frame of all the gravel alley data, and the second one is a data frame of all the paved alley data. And so the main function we'll talk about in per is the map function. And the map function is sort of like vapply or lapply. So when you run map on any vector, and a list is a type of vector, but it doesn't have to be a list, you can give it a function and then any arguments to that function. So let's say I want to get a list back, but I only want to see the first 2 data points for every level of alley. So when I run map here, I run it in this format where I give it the data set, in this case a list, tell it what function to run and any arguments that come for that function. And so when I get that back, you can see I still get a list back. Inside that list is embedded a data frame. I'll talk about this in just a second. And this has the first 2 rows for all the gravel data. And then this one is the first 2 rows for all the paved data. And you can see it's a list because it says $gravel and it gives you output. So what map does is sort of like a tidyverse clone of like lapply. Lapply runs code across elements of a list. So one thing I didn't really talk about that has been in the code here a few times that let me just back up is this idea of something called a tibble. A tibble is sort of the tidyverse equivalent of a data frame. It actually is a data frame, but it's got some extra rules associated with it. For one, it doesn't let you like partially declare columns. So let's say in this tibble, I type mini aims $ALL. If this were a regular data frame, you would get a vector back for alley because it autocompletes. It says, well, I'll look and see if there's any unique column names that start with ALL, and it finds one, which is alley, and it gives that back to you. Tibbles don't let you do that. We require you to put in the real name, the full name of it, or else it causes an error, just because we think that reduces mistakes. Another big difference in tibbles in regular data frames is, if I just select off alley with a regular data frame, like mini aims $alley, I get back a vector, so it drops the dimensions. Now you get the same thing with the tibble, but if you were to do that same thing with column subscripting, like mini aims bracket comma alley on a regular data frame, you would get a vector back. But a tibble, when you column subset using select or brackets, will always give you a data frame back, even if it's a data frame with one column. That to me is probably the biggest difference between data frames and tables, is unless you use a $sign way of subscripting, they do not drop dimensions, which again reduces quite a lot of errors. So when you see Tibble here, you can, if you've never used one before, you can immediately just think of that as, oh, he means data frame, which is essentially what they are. All right, so back to per. Map always returns a list back. So even if I give it like any type of vector here, map will give me a list back. The problem with this, and Caret has this all over the place, is many of us had a lot of code where we ran like lapply, and let's say we wanted the number of rows in a list of data frames. Well, the number of rows is an integer, and we want that to be like an integer vector, but lapply always returns a list back. So there are like probably all over CRAN, there's probably like thousands of places where people have said like unlist lapply, data frame and some function, because you wanted to get integers back, and lapply couldn't really do that. So there's a bunch of variants on map that are called like map underbar something. So map underbar int always returns an integer. So for example, if I'm going to get the number of rows by alley, I can run map int instead of map. As long as this function gives me integers back, I will get an integer vector back. So map always gives you a list no matter what the results are. Map int would give you an integer vector back. This is very, very helpful because you don't have to unlist stuff. So there's like map double, map logical, and things like that. So there's a lot of variants of this that are just like, just less code that you have to write, and it's very, very nice if you're doing the like data analysis and using map. Another really cool thing that we'll see in the notes a fair amount is there's a different way of calling map. So when I called it here, I use this sort of syntax here where I had to give it a function name as an argument and then any arguments to the function. That's a little bit limiting, and it's maybe sometimes hard to read. So another alternate way of using map is instead of being a function name for the second argument, you give it a tilde, and then you can basically write in like any sort of anonymous function code that you want here. And then the argument that gets given to this that is represented by the data is called .x. So .x is the placeholder for the data that map gives to that function. So for example, if I wanted the maximum sale price by alley, I can use summarize from dplyr, give it this, which is the data that's going to be passed into it, and then any argument I want to after that in line instead of doing it other ways, with the dots. So in doing that, again, I get a summarize always gives you a data frame back, so I get a data frame for both gravel and paved with the maximum price there. We'll do this a lot in code. So these are sort of like anonymous functions that don't exist after you call them. So their scope is only within map. And again, the thing to remember here is it has to start with a tilde, and then .x is a placeholder for the data that gets passed to it. So hopefully this is review for a lot of people, but it might not be. Okay. One thing you'll see in tidymodels quite a bit is something called list columns. So when we think about a data frame, Tibble or not, the rules behind a data frame, or one of them, is that for a given column of data frame, all the data under that column needs to be the same type. So, if we look at the penguins data, we have like species, that column is factor, right? So like row 17 of species isn't like a number, right? So column-wise, all the data underneath each one of those columns has to be the same type. And they're vectors, basically. So data frames are collections of vectors of the same length and so on, but they don't have to be the same type, right? So like in penguins, we have numeric columns and character columns and factor columns and things like that. What we can also do is we could also have list columns. So in data frames, in Tibbles, what we can do is, the elements of a list could be anything. They could be numbers, characters, data frames. There's no real restriction. So what we'll have in a lot of tidymodels cases especially is we'll have a column of a data frame that in itself has columns within it. So just as an example of that, let's take our mini Ames data. And what we're going to do is we're going to run the tidyr nest function. And that will say, if we say nest our data by alley, for every the unique value of alley, it's going to run basically like a row filter and return a data frame for that value of alley. So for example, using this call here will give me alley back because it's the nesting variable here. And then it gives me a data frame back for all the data that had paved alleys in my original data set and all the data that had gravel. So it's almost like a do-by sort of thing, but the difference here is we're returning an embedded data frame inside a list column inside of a data frame. So at the top level, like Ames list call here is a data frame. And one of the columns of that data frame, data, is a list column, and inside that list is tibbles, which are data frames. And you might wonder, like, well, why would you do that? We'll show you reasons later on. But just from a pure per point of view, if using per, what's nice is if you nest your data, then you can run like dplyr mutates, and inside of them get data on that data frame. So for example, if I want to have a column in my data set that's the number of rows of that embedded data frame, I could run mapint, run it across this list of data frames, run nrow and get that back, and so on. So there are instances where just the way the computations we do, this might be an advantageous way of doing it by embedding these data sets inside of a tibble or inside of a data frame. So we just want to introduce you to this notion of when you print out a data frame, seeing something that's a tibble in some dimension descriptions. That means that these are embedded data frames inside of a data frame. Okay. One thing other about these notes is we've tried as best we can to sort of like, I'm not really trying to be flashy here. We're trying to let you know the packages that are used on every slide. So if you're wondering, like, wait, what's this nest thing? We mentioned here that it comes from tidyr, but we show it up here also to demonstrate what packages we're using. All right. I don't see any other questions, but I'll maybe pause if somebody else has any kind of questions that they want to post real quick about the materials. We're about to do a hands-on session. So any other questions about the materials so far? Normally, like when somebody puts a question, I'll see that, say so-and-so is typing in Slack. I don't see that. All right, well, we'll proceed. You can still ask questions whenever you want, and I'll get to them. Here's the data investigation. So whether you're running on RStudio Server Pro or locally, what I'd like you to do is to run this code, which will make the Ames data available to you. So let me just do that in my R session. So I'll do this, and now I'll have Ames as a data frame I can use. That's not helpful. So let me do like a structure of Ames. And this tells me, if I look at the columns up here, it shows me that there's a column that says MS subclass. You don't necessarily need to know what that is. It's basically things related to the type of property. Like in this case, it's like a one-story property, 1946 and newer, all styles. This is something the assessor's office uses. More relevantly, there's things like alley and streets, whether streets paved or gravel, lot area, and things like that. So this is the process version of Ames. And one of the things we did here is, you might have noticed, is instead of being missing, we put in no alley access. So whenever we had missing data, especially in factors, we said like no garage or no alley instead of making them missing. So that's helpful when it comes to data analysis. So what I'd like everybody to do is we'll take 10 minutes. And one of my professors said something a long time ago that stuck with me, and I mentioned, and I don't know if he's the original person who said it or not, but what he said was the only way to be comfortable with your data is to never look at it. right? So a lot of times we get data and we're going to do something. We just start like cranking out models and things like that. What I'd like everybody to do is just like to do some exploratory data analysis. And that could be ggplots, it could be dplyr, summarize, it could be anything. But I'd like you to look at the variables here. You don't have to look at the outcomes. The outcome here is that we're going to be predicting later is called sale price, which is at the bottom. You can look at that or not, or you could look at like, hey, what's the deal with pools? Like, do people have big pools or not? Like, what's that about? And just investigate the data a little bit. There's a lot of really interesting things in this data. And so what I'll do at the end of 10 minutes is to, ask for people. And you can either unmute and speak, or maybe if you don't want to, like type in general, something that maybe you looked at and something you found interesting, or maybe it just met your expectations. I don't know. But just give us some sense of what you think is worth mentioning about these data. So I will hit the timer here. If you're having technical issues or anything like that, go ahead and start posting in technical. I'm going to mute myself, and I'll probably turn off my video too, and then just help people as they have questions. So let's go ahead and do that.